Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and encouragement and continuous feedback on every videos. And I'm wholeheartedly thank all of you. And today's topic of interest is grinding. So here I would like to clear one thing. A grinding tool is a multi-point cutting tool where each and every abrasive particles on the grinding wheel which is bonded by means of the bonding material. So each and every point of an abrasive will act as a cutting tool, a point of a cutting tool. That is why we are indicating that in grinding tool, in grinder, the type of cutting tool is multi-point cutting tool. And the process is very simple. So this is a finishing process. The grinding process is a finishing process, which is we can finish the surfaces. After all the machining process, after all the machining process in the component, the final process is a surface finish process that is done by the grinding. And also we are having a super finishing process is there the process which will give more accuracy and more surface finish can be done in super finishing process like honing, burnishing, lapping, like that. The processes are different for we are getting the more accuracy in all those process. The abrasive particles are used, the abrasive particles in different grades are used, we can say. So in the grinding process we can get more accurate shape as well as the dimension. So here, so this is the grinding wheel, which is rotated at very high RPM, say 1400 to 2500 RPM it is running. And the process of removing materials is upbraiding process. By means of an upbraiding action, that is continuous rubbing action, the material will be getting out. Here, the material removal is very small. In the grinding, material removal is very small. Like that, where the milling and drilling and grinding, we cannot see even the chips. The chips are in very fine powder form. That is the maximum thickness of the chip which can be produced by means of a grinding. Very uh, small chips can be produced, and it is highly finished process, highly dimensional accuracy is needed. So this machine, the grinding machine, should be well balanced and rigid enough to absorb all the vibrations. Even in a single vibration causes a dimension inaccuracy, so that the machine should be hugely rigid enough to absorb all the vibrations. And with this information, I would like to start the grinding process. Here, one thing you have to know, the grinding wheel is in a rotary motion and workpiece in stationary or oscillatory motion, or to and fro it is moving. So it is called as a simple surface grinding. Whereas if the grinding wheel is rotating as well as the workpiece is rotating, it is called as a uh, cylindrical grinding process. So, like that, the grinding process can be categorized with the how the grinding is occurring, like that. Today I'm going to talk very generally about the grinding process. Okay, so here coolant is very necessary. According to the component we are using, the coolant should be poured. The coolant will increases the wheel life, as well as it will absorb heats produced in grinding process, and it will suppress the very fine grinding chips, to the machine table itself. It won't let it the mix with the air. This background, I would like to start the grinding process. First of all, the grinding is done to get desired surface finish and the correct size and more accurate shape of the product and structure can be done. In grinding, we have two types of structures. One is open structure and another one is a closed structure. Where the open structure, it is for ductile materials, and the space between the grinds are more, therefore we can observe coarse grinds. Even this ductile is a very important phenomena of the selection of grinding structure. Generally, grinding is not preferred for more ductile material, and non-ferrous materials like aluminum, brass, copper, these kinds of a material cannot be grinded because the grinding wheel will get clogged. The grinding will get clogged. That is why the grinding is limited to the brittle and hard material. And core structure is preferred for brittle and hard material grinding. Here, the space between two grinds are less, therefore, we can get fine grinds. Now, we are going to discuss designation of a grinding wheel. We have a 7 letter alphanumerical letter to designate every grinding wheel. Here, the first and last numerical numbers will indicate the manufacturer specification. So this is called manufacturer specification, where we will have a very five designations of grinding wheel. So these 5 terms are very important in order to see what property that grinding wheel is having. So first and last are not at all important, whereas the middle 5 is very much important. That is why in this class I am going to categorize and I am going to designate these 5. Here, the second letter indicates type of abrasive. This indicates grind size, hardness, and this is structure, and this is type of bond. So this is abrasive, and this is grind size, and this is hardness of the grinds. This is the structure, and this is the type of bond. So this we have to understand. In this order, we have to designate the grinding wheel, and this order we have to read the grinding wheel. First, I go with type of abrasives. We have different types of abrasives like carbide, aluminum, diamond, artificial silicon carbide, that is carborundum or corundum. We can say emery. So these are types of abrasives we are having. So the first letter will be denoted as a type of an abrasive. For carbide, it is C. Carbide it is C. Alumina it is A. Diamond it is D. Emery it is E. And silicon carbide it is S. Like that, they have indicate the types of abrasives. The first letter, first alphabet will gives a type of an abrasive. Next is a numerical word, that is the next term, next designation is a numerical term, the third term. It will give the grain size. If the number is between 10 to 24, it is for roughing operation. When it is 30 to 60, it is for medium, and 70 to 180, it is for finishing, and 120 to 600, it is for super finishing operations. And the fourth term is the hardness. It represents the hardness. It is again an alphabet. So A to H, it is a soft wheel. Soft wheel. And I to P, it is a medium wheel. And Q to Z, it is a hard wheel. And soft wheel is for the very fine surface finish. And hard wheel, it is for the roughing work. And the fourth term is a structure. It is the number is from 0 to 16 only. When it is from 0 to 7, it is core structure, and 8 to 16, it is a open structure. And next, we have a type of bond. We have again a 5 types of bond is there. This type of bond, it is a sixth. It is the sixth designation letter. So fifth is the structure and sixth is the designation, and again seventh one is the manufacturer specification. So the last term before term is the type of bond. We have a 5 types of bond. One is vertified bond, silicate bond, resinoid bond, rubber bond, and metal bonds. So this likewise Likewise, the grinding wheel is getting designated. So with this, I'm going to stop my video. If you have any doubts, please let me know in the comment section. I will put definitely another video for your better understanding. Thank you. Thank you all. So until then, bye bye from Santhosh. Thank you.